Since there was a lot going on, I wanted to break this video into 2 parts. So this is part 2. We've already gone over where the function is constant, where it's increasing. We've gone over the domain and range, so now we're going to look at where it's decreasing. So let's see, we'll do this in brown. Now I'm going to look for where the line's going downwards. Like it happened a few times here. So we got quite a few intervals here where it went down. So here's how I can approach this. I'm going to look specifically for, again, remember, domains is what we're concerned with. We don't really care about the range here. So I'm going to go with decrease. Let's start thinking about these decreases. Where is it happening? Looks like we have it happening from 2003 to 2004. Again, I'm going with the brackets because we've got solid dots going on there. If there were dots that weren't colored in or points not colored in, now we'd be going with parentheses. Now, this isn't my only decrease. I got more than one going on. I got, frankly, quite a few of them. So I'm going to use the U. Remember, don't use commas, don't write ands. Use the U. That means union. That's, more than one thing going on. Now I got 2007 to 2008. Okay, I'm going with the U. And now I have a couple options here because I got 2010, 2011, and also the 2012. I could do these intervals separately, like 2010 to 2011, then 2011 to 2012, but I'm going to go with just one large interval here. Just going all the way down from 2010 to 2012, I'm going to cite that as my range of decrease. Okay. And let's see, I'm just going to shrink it. Gotta love technology, guys. I'm going to put my U in here. Now, let's see. It looks like I cited a decrease that didn't happen. That's not a decrease. That was an increase. Again, I got another 2-year. Oh, boy. Those weren't going good. Weren't going too well then. So we're going to go with 2013 to 2015. Can I squeeze it in? Yes, I can. And then I got one more. All right, I'm running out of space here. I'm going to have to get a little bit creative. I'm going to move this on down. I'm going to slide over here. I'll slide on the side here. Still plenty of space, right? So then we're going to bring over this little notability lesson for you guys for using this. I like the program, notability. Got a U, okay, and then I got one more range here, 2016 to 2017. As I was saying before, this type of stuff can be very useful. This is something that gets used. Chances are Amazon executives might have sat down and said, what was going on in these years? Was there a recession? Did we have some delivery issues? Maybe someone was in charge that, they noticed that there was customer satisfaction going down. So these would be things to pay attention to. So let's see, I've got it increasing, decreasing, constant, range, domain, continuous, discrete. I would go with discrete just because you can't really have like 2008 and 4/17. You have a set of values. It looks like they're just measuring this every year too. You could make an argument that could be continuous because you have the lines going on here. Now, linear or exponential. Looks like it's neither linear nor exponential. The reason is there's nothing consistent here. Got something flat, goes up, flat, goes down. I could come up with a condition. I could come up with conditional rules here. I could come up with equations that would fit. But for sake of what we're doing, we're just going to say it's neither exponential nor linear because we don't have something straight. Whereas if it were linear, we might end up seeing something go like this, where it's just a constant rate. If it were exponential, I should probably have done that in black, but that's okay. If it were exponential, chances are I'd be seeing something like this, nice big curve, but I'm not seeing that. All right, is there anything else? I covered the units and the increments. I'm in pretty good shape there. Covered whether it was linear or exponential. There are some other important things I can note here too, like my y-intercept. Now, in this case, I don't necessarily have an origin, but I guess I could consider my origin of 2000 here. But typically for a y-intercept, you want your input to equal 0. We don't necessarily have that in this case. For an x-intercept, we want our output to equal 0. We don't necessarily have that in this case. You could get creative and call this your x-intercept, call this your y-intercept, but I think for what we're doing, we wouldn't necessarily do that. So we've covered all the important characteristics of this graph. Now we have a couple of questions too. F of x equals 84. This is asking me, when is my output going to equal 84? Let's see, when did that happen? Let's get our scores here. Oh, we had it in 2000, 2001, 2004, and those are my years. So I'm going to go back down to here, and x would equal 2000, 2001, 2004. What that means is, in those years, the score was I think it was called the ACSI. Let's see, I'm going to check this is where it comes in handy. Yep, the ACSI, awesome. I'm going to say the ACSI was 84. Now, this one's a little different. It's telling me when my input is 2004, what am I getting for an output? So I could come up here and, hey, well, you know, for 2004, I got 84 as well. So when my input's 2004, I get an output of 84. So in 2004, my score was 84. The ASCI was 84. So there you go. We've covered all the basics on this Amazon function here. Wasn't easy, but I wanted to give you guys something represented by real life, and I figured it would give you guys some real perspective on doing functions with interval notation and how it applies. Hopefully this helped your understanding a little bit.